Now let's continue into part 2 of this video. So continuing on from our previous 4 common network-based attacks, I've got 4 whole more. As I was sort of going through the first kind of few, I thought, okay, I've got some more that I'd also love to cover. And the first one here that we're going to talk about is our interception attacks. I'm going to write intercept just for short here. Let me just clean that up a little bit. Intercept attacks, and these are commonly across either through network routing protocols, network switching protocols, and think of this in terms of any attack where an attacker can intercept the data. Right? We've got maybe file transfers. Let's write file transfer, and then we've got things like maybe email, maybe web browser functions as well. And it's typically anywhere where the data could be picked up, sniffed, intercepted, right? So common prevention, encryption, right? We want to make sure that as that data leaves our organization, both in transit and at rest, the data is encrypted. Going back to our CIA basics, our confidentiality, the data is encrypted. Therefore, no one that or anyone that tries to intercept that data can't read it. It's all mumbo jumbo. And the only way they can decrypt it is if they have that key. So intercept attacks, be mindful of those. Then we have our denial of service and our distributed denial of service attacks. So this is commonly any time an attacker tries to use up all the resources. So attacking resources where they no longer have the ability to handle the requests. Therefore, it results in some sort of service disruption or not being able to use that service or that feature or that function of that, maybe that infrastructure or that web server typically kind of happens. So if I'm going to go away and let's say maybe this is our DMZ zone and we've got a couple of web servers or we've got some DNS servers. And if we go away and we start sending in 10,000 requests, 20,000 requests, trying to use up all the service or try to use up all that memory of that host, well, that's going to cause a service disruption, right? So we're going to be utilizing and eating up the CPU. So CPU, memory, these are common factors or common sort of features where these types of the CPU and the memory get tied up, right? So they will get consumed, and then obviously when there's a legitimate source that comes along for like a user or maybe a customer that comes in and requests access to that server, well then they won't be able to access it because it's being tied up through this malicious intent. So prevention mechanisms for our denial of service. Well, firstly, I would say is that to have some sort of edge technology with DOS or DDoS prevention, right? So if we've got our edge environment here, implement here. So I'm just going to put in our technical edge. And over there, you would have things like rate limiting features, right? So rate limiting is a very common prevention mechanism that you can put in place. That way, instead of these 10 or 20,000 requests coming in, or maybe we're not going to accept all of those, we'll probably accept maybe 5. And then we'll set a threshold, maybe it's every 5 minutes. That way you can sort of rate limit, again, going back to that sort of prevention side, it's rate limiting a number of connections that are coming through and at any specific given amount of time. So we specify the amount of time, and then that way, that way it sort of goes away and then rate limits those sessions and those connections that are coming in. So then we've got our denial of service providers. So I'm just going to say rate limit number 1. Number 2 is service providers. There are denial of service and distributed denial of service providers. Think of these like Cloudflare. Cloudflare has been around for some time, and then basically these guys will act as that middleware service. So they will be sitting on your edge, and then as the traffic comes through, they'll go through your Cloudflare environment, and then they'll access the resource. So they kind of act like the buffer, and they're the sort of the go-between between the users or basically the users, the access and the data, right? So they'll go through the provider to access the resources. Therefore, they will filter out any sort of gooply gop, and then you can manage how we sort of rate limit and access that environment from there. So then we've got our service providers that go away and do that, and then we've also got this distributing of data. All right. So instead of having all our data in one geolocation, well, what happens if I go away and over here I can put up another location? So there's durability between different locations to access that certain environment. So rather than it being hosted in a central location, so maybe this is in, in Sydney, maybe this location will be somewhere in maybe New Zealand. So there is a different state or geolocation, so the data isn't all in one spot, so we can session up the data. Okay, moving on. So we've got VLANs, which is another very common layer 2 attack that we can perform. And basically, as we talk about VLAN, so if I've got a switch over here, and let's say maybe this is a 48 port switch, so I'm just going to session this up. It looks more of a window, but think of this as a switch. And I've got a couple of switch ports here. And then what I can do is, if I'm an admin, I can go here and I can tie in parts of this infrastructure to different segments. So I can say, okay, well, the red component over here is associated with VLAN 1, and our VLAN 1 is our engineering team. Okay, and then VLAN 2, our VLAN 2 is our HR team. And what would traditionally allow, what would happen is on a common layer 2 environment, we can limit the communications because they're on the same switch essentially, but they can't talk to each other, right? So they're in different VLANs. So the engineering team cannot talk to the HR subnet. So what would then happen is we'll have to route this traffic out into a layer 3 switch or a router essentially, and then the router will perform. We can put in some access control lists that we can say, well, if the VLAN 1 comes through, we can allow it to communicate to VLAN 2 and vice versa, right? So we can go away and commit some, put in some administrative controls on that layer 3 router, if it's a layer 3 switch, or the router itself. So we want to separate those connections out, right? So that's what VLANs are. So they're there to create this local area network. It's logical, and then we can segment up our switching infrastructure, right? So VLAN hopping comes into play when we've got access to a certain switch port. Maybe the attacker has a switch port here, and then we can begin communicating to other areas of that switch port, meaning we don't need to go all the way up to that router. So being challenging because we can actually hop between those VLANs without going through that layer 3 device. So that's our VLAN attacks. So what are some common prevention mechanisms? Well, there's a couple that I can think of as I'm kind of writing this out, right? So the first one is native VLANs. Native VLANs are very common because any sort of layer 2 attack that we tend to do, you start to see that once we've plugged into a network or a switch port over here, you get pulled. And I say pulled because you'll see where I'm going with this in just a moment. So we get pulled into this native VLAN. If you're unsure what a native VLAN is, think of this as a default VLAN. And that's a bad thing, right? We don't want to have a default VLAN where you've got servers and you've got hosts. That are all connected. So specifically what a default VLAN allows us to do, and think of this as a native VLAN, the default VLAN for a lot of those switches is default VLAN 1. So you get put into this default VLAN 1, well, that's a bit problematic, right? So again, if there's any resources assigned to that native VLAN, like servers and hosts and stuff like that, well, then we would be able to see those hosts or those servers. So what would then I would assume that many people that are listening to this is you take that default VLAN and you give it you assign it, right? So you'll create maybe an unused VLAN. And then within this unused VLAN, you would give it another port. So instead of VLAN 1 being the default, you want to give this another VLAN like 99 or whatever that VLAN is, right? So it's a pretty much a black pooled VLAN, I would say, and then you pretty much pull in any unused resource. Then you assign those unused ports to that default VLAN. So then you can say, well, if anything's not being used currently in these switches, then they'll fall into VLAN 99, and VLAN 99 is a black pooled VLAN. I kind of call it as black pool because it doesn't go anywhere, doesn't talk to anything. They're unused ports, and that's the way you want to do it. So should anyone plug in, and you should have some sort of switch port access controls and stuff like that. I'm not going to cover that in this video, but you want to make sure that those ports are not used, and if they are used, then they're assigned correctly and stuff like that. So unused ports, put them into an unused VLAN, configure that unused VLAN, make sure that all default traffic goes into that unused, or there's unused ports going to that default unused VLAN. And then finally, we have our social engineering. And social engineering, it's basically deceiving people or systems for information, right? So we want to go away and ask people to validate or confirm, or basically people and the willingness to give information out that could potentially come back to bite them in the bum or cause some sort of business disruption. So I've got a whole nother sort of series around social engineering. I'm not going to cover it in too much detail, but that's just the concept, right? It could be physical, it could be through SMS attacks, it could be through, a spear phishing attack. Maybe you're spear phishing specific executive leaders in an organization, and you've crafted a message very specific just for them. So you want to sort of get them to divulge, give out information. Maybe it could be credentials, maybe it's wireless access account passwords, maybe it's getting access to a cubicle or a specific room or a specific, building location. Maybe you have to go into a building and, there's a receptionist that's sitting over here and she's lovely, and you bring her a box of, chocolates. And then before you know it, she's let you into the building because, she's seeing you around, you got familiar with the face, and that all comes down to social engineering and deceiving that lovely receptionist to give us access to something that she shouldn't have. So some prevention mechanisms for social engineering. Well, first one is education. And education plays a profound role when we're creating user awareness training for staff. It's making sure that the users are educated, they're trained, there's a proper approach and process. That way, if we do, or if this, let's call her Jan, and Jan is a receptionist, then Jan has a clear communication path. So I'm just going to say comms path. So she knows who to communicate to. Should a stranger knock on the door and ask and get access to a certain area, there should be a document process. That way she can review documents and policies and stuff like that within the organization. There's obviously a procedure that takes place. If something happens, there's a process and procedure that is underlying within the organization's information security policies that way that we know what to do in this sort of attack, and obviously training and educating users to look out for these things and become a good advocate for any sort of social engineering attacks. So again, the goal of social engineering, and obviously what we should do about it. So they're the other 4 common network-based attacks. We've got our interception attacks. We've got denial of service that we spoke about. VLAN's very common in our layer 2 environment, and social engineering. Again, I thank you all for viewing. I hope you've enjoyed this video. And as always, see you in the next video.